So, let's go.
Number 12. You are already doing it. Most people think time travel means stepping into a shiny metallic machine and popping out in the 1800s. Standard physics says something simpler and far more unsettling. You're already doing it. Every object in the universe moves forward through time at exactly 1 second per second, measured along your personal trajectory, your world line. That's relational progression. That's the baseline rule. Here's where it gets strange. A housefly's nervous system processes roughly 250 frames per second versus the human 60. To the fly, everything unfolds in slow motion. Its physical clock runs the same as yours, but what it actually experiences inside 1 second is completely different. You're both locked into the same 1 second per second, but you're in separate, biologically isolated bubbles of time that never touch. You can't speed up, can't slow down. You're strapped to a conveyor belt heading toward the heat death of everything, and there is no stop button. Number 11. Velocity time dilation. If you can't stop the belt, you can at least warp it. Einstein's special relativity gives us the first physically validated mechanism for time travel. When an object approaches the speed of light, its time runs slower relative to everything else. The math is the Lorentz factor, and the faster you go, the more extreme the effect. Twin paradox. You leave Earth at near light speed, come back. Your twin aged 40 years. You aged 4. Their clocks ran faster, yours crawled. One direction only, though. To cross the light barrier would require infinite energy for anything with mass. You can race into the future, but reducing your speed just catches your clock back up to the standard rate. The decades you skipped stay skipped. You come home, and everyone you ever knew is dead, and the future has no idea who you are. Number 10. Gravitational time dilation. Speed isn't the only trick. Mass works too. Closer to a gravitational source, time runs slower. This is a real daily calibration problem, not a thought experiment. GPS satellites move fast, which slows their clocks by roughly 7 microseconds per day. But they're also far from Earth's gravity well, which speeds them up by 45. Net, they gain 38 microseconds daily. Without constant correction, navigation errors would pile up at several miles per day and the whole system falls apart. Park near a black hole's event horizon and time outside races forward while yours nearly stops. Pull away and you emerge into a future centuries ahead. What you'd actually find there is the part worth sitting with. Every star and person and civilization you knew, gone, none of it waiting for you. Number 9. Wormholes going forward is manageable. Going backward is a different problem entirely. The most theorized route is a traversable wormhole, a tunnel connecting two separate regions of spacetime. Einstein and Rosen described a version of this in 1935. Useless, though. Anything crossing the event horizon gets crushed before reaching the other side. Morris and Thorne worked out a traversable metric in 1985, a wormhole where a traveler free-falls through without dying. Their math holds. The issue is what the equations require to keep the throat from collapsing. Exotic matter with negative energy density, which breaks the weak energy condition in classical physics. The Casimir effect produces small negative energy analogs between close conducting plates, but generating enough to stabilize a macroscopic wormhole throat is a completely different scale of problem. To travel back in time, you'd need matter that weighs less than nothing. Number 8. Closed timelike curves. A closed timelike curve is what happens when spacetime bends so severely that moving forward in time returns you to your own starting coordinates, in time and space both. Intense gravity or unusual spacetime topology can tilt the light cones of nearby objects until they loop backward. Gödel worked out a rotating universe solution in 1949, where this happens past a critical radius. The Kerr metric for a rotating black hole has the same property inside the Cauchy horizon. Tuesday leads back into Monday. There's one hard constraint on every proposed CTC: you can't go back before the machine was built. This is the clean explanation for why future tourists haven't shown up. The infrastructure doesn't exist yet. But a naturally occurring CTC, which the math doesn't rule out, is a different situation. Anyone who falls into one replays the same stretch of time indefinitely. Not as a metaphor, the same moment, looping, with full awareness of it. Number 7. The Tipler Cylinder. Tipler showed in 1974 that a sufficiently massive cylinder, at least 10 solar masses, compressed and spun at several billion rotations per second, would warp nearby spacetime hard enough to tilt light cones backward. A spacecraft spiraling tight in the right direction shifts back in coordinate time. No exotic matter in the original design. The catch is infinite length. Tipler's solution required it. Hawking showed in 1992 that any finite version either collapses into a black hole or produces curvature singularities that terminate the traveler's worldline. Preventing either outcome requires negative energy. You're back to exotic matter. Try to build a time machine out of regular matter, and the universe folds it into a singularity. Reality enforces this. Number 6. Cosmic strings. Cosmic strings are hypothetical one-dimensional defects left over from the early universe's phase transitions, roughly atom width, but an inch of one weighs 40 quadrillion tons. The surrounding space is flat but conical, like a circular sheet with a wedge removed, which warps light and matter in unusual ways. In 1991, Gott proposed using two of them moving in opposite directions at 99.99992% the speed of light. A spacecraft taking a specific path around both exploits the relativistic simultaneity shift alongside the conical geometry and ends up crossing its own past world line. You could arrive before you left. The strings want to collapse. Their internal tension behaves like an extremely massive rubber band. Getting them to the required configuration causes them to snap together and fall into a black hole before the maneuver completes. The universe offers a shortcut and then destroys it when you try to take it. Number 5. Quantum tunneling in time. When a particle hits a barrier greater than its kinetic energy, classical physics says total reflection. Quantum mechanics allows the wave function to penetrate the barrier and occasionally emerge on the other side. Tunneling. It's real and measurable. Thomas Hartmann predicted in 1962 that above a certain barrier thickness, tunneling time saturates, it stops growing with barrier width. As the barrier gets thicker but the time stays flat, the implied velocity diverges past light speed. Experiments with microwave signals have measured effective transmission at up to 4.7 times light speed. This doesn't violate causality. The evanescent wave isn't propagating, it's a static field leaking from both ends simultaneously. No physical information crosses faster than light. The apparent superluminal speed is an artifact of how you're measuring. What stays with you, though, solid matter has no firm obligation to stop particles that have somewhere to be. The walls are negotiable. Number 4. The block universe. Time doesn't flow. That's what Eternalism says. Past, present, and future all exist equally as a static four-dimensional structure. The dinosaur extinction is happening right now, just at different coordinates. Special relativity gives this empirical support. There's no universal now. Two observers in relative motion slice the four-dimensional block at different angles. What one experiences as present, the other experiences as past or future, depending purely on their relative speed and position. Now is a local indexical marker, like here for space, not a privileged physical state. If the block universe is correct, your entire life is already written. Every choice you think you'll make has been made. You're running through a script that was settled long before you existed. Time travel isn't changing anything. It's navigating between coordinates in something that never changed at all. Number 3. Tachyons. Gerald Feinberg named them in the 1960s, hypothetical particles born above the speed of light. To satisfy relativistic equations while moving superluminally, they need imaginary mass, negative squared, which keeps their actual energy and momentum real. Their kinematics invert. Lower energy means higher speed. Stopping one at light speed requires infinite energy, just like accelerating normal matter up to it. The light barrier is symmetric, impassable from below and above. If they exist, you could build a tachyonic antitelephone. A superluminal signal in one reference frame appears to move backward in time in another. Timed correctly, one observer receives a reply before the other even sends the message. Cause follows effect. Physicists patch this with the reinterpretation principle. Any backward-moving tachyon with negative energy gets reclassified as a positive energy antiparticle going forward. The math stays consistent. Causality survives. What doesn't go away is this. If tachyons exist, something out there experiences our universe in reverse, watching deaths unhappen, watching cups reassemble. running on a logic that makes ours look like an arbitrary local convention. Number 2. The Novikov principle. You've made it back. You're standing in front of your grandfather. What actually stops you? Igor Novikov's self-consistency principle. Only globally self-consistent solutions can exist in the real universe. If an event would create a paradox, its probability is exactly 0. The laws of physics arrange themselves around this. Your gun jams, a bird appears, you trip, not by any guiding hand, but because your failure was already part of the record. The record doesn't allow contradictions. Polchinski modeled this with a billiard ball fired into a wormhole, aimed to exit in the past and hit its younger self, preventing the shot. The calculated outcome: the ball delivers a glancing blow that deflects it just enough to enter the wormhole at the angle required to produce that exact glancing blow. It resolves. Clean. What this costs you is free will. If the past cannot change, every attempt to change it fails by exactly as much as it needs to. You are executing a script. The choice to pull the trigger, the gun jam, the walk home, all of it was always going to happen, in that order, and nothing you do alters it. Number 1. Quantum many worlds and timeline branching. Hugh Everett's many worlds interpretation. The wave function never collapses, it branches. Every quantum outcome happens, in a parallel world, every time. In 1991, David Deutsch showed that CTCs in this framework resolve the grandfather paradox without Novikov's self-consistency requirement. You go back, create a contradiction, and the system settles into a mixed state. You branch. Your original timeline keeps running, untouched. You're now in a new branch where the altered history unfolds. Entangled timelines models suggest these branches emerge locally from quantum entanglement between the time machine and its environment. No paradox. Causality preserved, but what it actually costs you: don't change your past, you leave it. Your friends, your family, everyone you knew, they experience your disappearance. No explanation, no note. You arrive in a parallel world full of near-perfect copies of people you love who have no idea you came from somewhere else and left something behind, and you're not a clean arrival. Your body heat, the air you displace, your microbiome, all of it begins propagating through the branch timeline immediately. The butterfly effect compounds over decades. You weren't trying to cause harm. It doesn't matter. You're a small catastrophe with good intentions in someone else's history. We point telescopes at the night sky and dream about mastery, going back, fixing things, getting a second pass. The physics doesn't describe mastery. It describes a static block that's been finished for billions of years, a light barrier that only goes one direction, and a multiverse that keeps splitting whether we want it to or not. We're not steering. We're coordinates in something that never asked us. If you want to keep staring into the void until it stares back, subscribe. I'll see you in the next one.